start talking about the lesson and what's coming up. We need to finish the bell work. Let's go ahead and do that. Next line, silicon 4 oxide. I just said it was what? Covalent. And unfortunately for you, you have to recognize that silicon 4 oxide is the same thing as silicon dioxide, which is SiO2. How's that so? How does that work? How could we have interpreted silicon 4 oxide to know that that's SiO2? Could you have figured that out?
Yes.
Because technically, from a knowledge of previous chemistry, you could figure that out. So I could put that on a test. Wait, just being with you. How?
Because the 4 is the charge for silicon.
Right.
So that's yeah.
That's crazy.
Yeah.
That's
And
crazy.
then
But
put this.
you figured that out yourself.
But it's actually not the charge because it's covalent. It's the unofficial charge, which is called the oxidation number. Oxidation number, which I know you said you hated that topic, but that is in the next unit. But it does predict that we get SiO2. That is SiO2. And so what is the type of lattice structure? You just saw it. I just showed it to you. I pulled it up from the last lesson. It's one of the ones you got to memorize. It is giant. So the way that they wrote this out was kind of like to throw you off. They did it on purpose. Iodine. What's that? Well, what is it? Is it a single atom? Side 2. Right? That's the standard state. Standard states are coming. Next unit. They're going to be there. It's all going to be unit 3. So you could just, that's a second quarter exam, but, some of it's going to show up on the quarterly. What type of bonding for I2? Covalent. And lattice structure, because it is just an iodine and another iodine? Simple. It has a beginning and an end. It's like that. It's literally 2 atoms. Simple. Yes. Sodium chloride is salt. Covalent or ionic?
Covalent.
Ionic. Metal and non-metal. And ionics are always giant. And that's something you should learn. Ionics are always giant. Which means they'll have high melting points as a result because they're giant. Giant structures have high melting points. Okay. That was the first 5 marks. This was given in the 2017 exam. Still fair game. All of these standards are still fair play. So I can pull questions from old exams as long as the standards are still in line. And chemistry hasn't changed a lot over the past 20 years. It has changed, they've changed a little bit here and there. So there's some questions I have to take out, but this is still completely in our standard. Next, this is a newer question. I noticed I crossed out oxidation state because I haven't taught it yet, so I wouldn't intentionally give marks for that on an exam unless I did it as an extra credit thing, like extra marks. But other than that, no. Bonding. NaCl. Same thing. Bonding, ionic or covalent. They tell you to use the letter I, M, and C, and G, and S. So bonding for NaCl? I. Bonding for AlCl3. Did you get got by that one? Bless you.
Thank you.
Remember that this was the exception. And it combines with another one to become Al2Cl6. But this is a covalent molecule, isn't that? That's covalent. Which means if that's covalent, then everything else must also be covalent. Because these are going across the periodic table, they're more like non-metals. So if this is covalent, then these obviously have to be covalent. Right? Structure. NaCl. All ionics are giant. Are any of these covalents one of the giant ones? Are they diamond? Are they graphite? Are they graphene? Are they SiO2?
No.
Or Si? No. So every single one of these is simple. You can draw out SiCl4. It has a beginning and a ending. It's tetrahedral. We could ask the bond angles for that. I could ask the hybridization for this. Oh, angles, hybridization. What's the bond angle for SiCl4? Bond angles, 109.5. What's the name of the shape? Tetrahedral. Is it polar or not polar? Polar. What type of hybridization does it have? P3. How many sigma bonds does it have?
4.
How many pi bonds does it have?
That's crazy.
What's its strongest intermolecular force? Yes. Wow, we learned a lot this unit, didn't we? That means for any molecule, I could ask you any of that, right?
Wait, what's the SP3 thing?
That's to count the groups 1, 2, 3, 4, S, and then 3 Ps.
Yeah.
Anything tetrahedral will always be sp3. Anything trigonal planar will always be sp2. Because it's how many groups there are around the center. So, on that note, we did this. Now, let's talk about what's going on. I actually made a change. And I've been thinking about doing this for a few years, so you're the lucky students. I used to teach this final lesson. I used to do a math topic. I decided not to. I guess you're welcome for many of you. I will wait to introduce moles until next unit, so you won't have math on this test next week, beyond, counting. But, what? I've been meaning to for a while. What has happened in the past is I teach all the topics, and then there's these 4 lessons that don't really fit neatly into any one spot, so it's kind of like an addendum list of topics. And this was one of the lessons actually of those 4. So what I'm trying to do this year is integrate those lessons into the regular units so that there's no random unit at the end of the year. Everything makes a little bit more sense. So it means that a couple of our units are going to be a little bit longer than I've done in a couple of years. So instead of 7 lessons, there might be 8 or 9. But what I'm trying to do is get rid of one of the unit exams. And so the goal is to try to end just a little bit earlier if possible. We'll see. So this is actually a topic that is much better fit into here than at the end of the year. And guess what it is? Periodic trends. So periodic trends, you've already actually seen a few of them. You've been told to memorize a few of them. But when Cambridge tests, they like to test everything together. So we're going to take a look at the rest of the periodic trends you need to know, along with the review of some of the ones you've already seen. And so I really won't test too much on the ones you've already seen, except to integrate them into what we have learned here. So you'll see in the questions why I'm bringing this up. So Unit 2, Part 8, periodic trends. This is the final lesson of Unit 2. Final lesson, Unit 2. Final lesson of the unit. I anticipate it's not going to be that long. If you look, it's really not that long, and some of it's just a repeat of what we have already learned. So this is actually going to be a pretty short lesson. At least that's my goal. Instead of bogging you down with something that's heavy math and you're going to do periodic trends in your final lesson of the unit, which is something that you did in pre or you did in honors. Probably. But you need to take a better look at now and how it interweaves with intermolecular forces. What are the trends that interweave with this unit? And so that's why I put it here. So I'm shifting just a couple of things around. I relisted the objectives. These are the objectives from the syllabus. Notice how late it is. That's topic 9. We're actually, all of our other objectives were in 4 and 5. So that's why I said there were these little topics that I just threw at the end of the year in prior years, and I've been meaning to do this for years, trying to integrate them better into the content, and this is one of them. So periodic table, what we're going to be looking at today. Periodicity of physical properties of the elements in period 3. What is a physical property?
Liquid, solar, or gas?
So physical property can include state of matter. Which we would refer to as melting point and boiling point. What else can a physical property be? And I mean, if you look at the slide, it kind of, illustrates them. What are the physical properties could we talk about? Melting point. What else is a physical property? It says periodicity of physical properties. Apparently, if it conducts electricity, right? So conductivity, then, what else does it say here? So science. We actually already learned this. I'm gonna briefly bring it back up, but I taught this in Unit 1 to you. That's why I said this kind of like, it's a weird spattering of information. But we just learned electrical conductivity very recently. That we learned in Unit 2. So we're gonna bring that into periodic properties and how does that work. What elements are electrically conductive? So we know that the metals are electrically conductive. Do we know something that increases their electrical conductivity? Do you remember I taught it in the lesson, so maybe you don't? What increases the electrical conductivity? The amount of what?
Minerals and water.
Valence electrons. So we would be looking for increasing amount of delocalized electrons. Remember that word delocalized? The electrons in the lattice are not exactly attached to the nucleus that are the valence electrons, but they float through the C. You have to remember that. And so that's what we're talking about there. And then objective 2. Explain the variation in melting point. Melting point. Have we learned about melting points this unit? And electrical conductivity in terms of structure and bonding. So this is totally in this unit. This is definitely a topic that's in this unit. Variation in melting point. When we look at melting point, what should we always be comparing? If I am asking you what melts at a lower temperature, water or methane, what would you compare? Whenever you compare melting point, you should be comparing forces of, compare forces of attraction, which we call intermolecular forces usually. But you have to compare the attractive forces. The more attractive forces you have, the harder it is to melt. The weaker the attractive forces are, the easier it is to melt. So that's what we're going to be comparing today. It says, explain the variation in melting point and electrical conductivity in terms of structure and bonding of the elements. And it says for period 3. What are our elements in period 3? So we're going to be looking to compare sodium, and then what else? Magnesium, what else? Aluminum,
Silicon,
silicon,
phosphorus,
sulfur, chlorine, and argon. This is the comparisons that they're going to make in periodicity. So what's happening across the period for electrical conductivity, and what's happening across the period in terms of their melting points, and you could also say boiling points. Because the same trend for melting point is true for boiling point. So, I guess we'll go back to that in a little bit. I'm sure we can make some deductions already on what the trends might be. Like which elements are going to conduct electricity well versus which aren't. Which ones are going to have the high melting points versus which ones aren't. Let's find out. Beforehand, this is actually the introduction to this section, is the structure of the periodic table. And there's no standard here, but you do need to know that elements are arranged by increasing atomic number. So it goes 1, 2, 3, 4, 5, 6, 7, 8 in order. That's the amount of protons we have for each element. One thing that you should note, this is super, super, super important. Underline that. Elements in the same group have similar properties. So although Cambridge asks you to know period 3 by heart, that's sodium through argon, you can apply the ideas of that period to other periods. So like, I have seen them ask about gallium instead of aluminium, and you have to draw the same type of conclusions. You're like, because I know aluminum does this, gallium is in the same group, so it should do something similar. Does that make sense? So elements in the same group have similar properties. That's something you need to remember. Really important because it expands the scope of the type of questions you could be asked. And then the patterns we see across the period, this has a fancy word, it's called periodicity. So just real quick, see if you remember this. Which element is found in period 4, group 17? What's that? Like finding coordinates. Bromine. This is definitely nothing I've ever seen a Cambridge question on before, like an actual Cambridge test question. I've never seen them ask that, but this is from the textbook just to check that you remember things about the periodic table. Why are the elements in groups 1 and 2 known as S block elements? Why are elements in group 17 known as P block elements? Do you remember that one? It's actually in unit 1. We learned that. Why are elements in group 1 and 2 known as S-block elements?
Because the wavelength electrons are in the s orbital.
Checking.
Energy. Energy field?
Justin?
Then they'll have two electrons. Then you have two
Two metals, electrons.
So electron configuration ends in S for groups 1 and 2. This is literally just saying the thing that I taught you before, that this is the S section. The electron configurations here will always end in S. Like sodium's 3s1, magnesium's 3s2. Whereas group 17 would end in P block because same idea. Electron configuration ends in P. Ends in P for group 17. Oh, and I was going to say, before I go on more into the lesson, like I said, this is actually going to be a pretty short lesson today. I have built into today's time a gym kit. So we are going to play a gym kit today at the end of class. What? Third game of the week. You played gym kits this week?
In sociology.
Ah, yeah. Cool. And the gym kit will have shapes, bond angles, like all the different things we learned this unit could show up as questions. I was working on it last night so that you had something a little bit fun before we have the full review day on Monday. Don't forget your projects are due Sunday night and you're presenting on Monday. That's next class. Sunday night, Monday day. And test is what day?
Wednesday.
Wednesday. And I'm going to do a tutoring review on Tuesday. All right. So, periodic patterns of atomic radii. I am not spending much time here. Why? This was taught in Unit 1. But what you need to remember is that as you go across the period, for any element, the size always gets smaller. Why does it decrease across the period? That's what I just said, across the period. Period 3. Why does it decrease? For protons. Another way of saying that is increased nuclear charge. And then why does atomic radius increase down group? Just to remind yourself.
More electrons. More shielding.
More shielding. And the valence electrons are further from the nucleus. So that's greater distance. That's just a fill in to remind yourself. So are these topics going to show up on the quarterly? You can bet. But now I can ask you after today's lesson any comparison of periodic trends. Because we're filling in the last few that Cambridge has, they want us to know. This one we already learned. Across the period, elements get smaller. Down in group, elements get larger. For ionic radii, you have to also know the trends, which I also taught in Unit 1, so I'm going to be quick there. Ionic radii, this is like literally copy-paste from Unit 1. You just have to remember if you have an anion, it's larger. If you have a cation, it's smaller. So you get this weird little trend that it goes down, 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 and then it jumps up. Why was there this big jump? From here, the cations, you only have 10 electrons. For all the anions in the same group, you have how many electrons? You actually have a full another level of electrons here. And so it jumps in size significantly. So in this trend, and you do have to, the reason I'm bringing this up is because they're going to show you graphs, they're going to say which trend is this, or which periodic property is this. Ionic radii goes like this, down and then jumps up and then down again. Kind of like, I don't know, like a conductor, right? That's ionic gradients. But we've already learned this. This is something just to review from Unit 1. Now, here's what's new. Periodic patterns of electrical conductivity and melting points. See if this makes sense. Electrical conductivity increases from the elements sodium to argon only from sodium to aluminum. Why? So between sodium and aluminum, aluminum will conduct electricity better than magnesium, and magnesium will conduct electricity better than sodium. Why is that? This is group 1, right? Group 2, and group 13. They're all metals. More what? More stable. Electrons. Is what you're looking for. And then, you can see this is some data that was printed in the Cambridge textbook. Electrical conductivity goes from 0.218, 0.224, 0.382. What's 2 times 10 to the negative 10?
0.00.
Point. That. Is that smaller or larger than 0.382?
Smaller.
Like a lot smaller, like approaching nothing. But not as much nothing as the next one, right? Because that's a 10 to the negative 17. We'd have to write out 10 to the negative 23. We'd have to write out. So these are very small, right? Like why? Why are these all approaching 0? Why is there literally like no electrical conductivity from silicon and Bi?
More nuclear parts.
Electrons are stuck. That is a good way to put it. These are metals. These are non-metals, right? So bond is covalent when they connect to each other. No spot for electrons to move means electrons don't move. Yes? So this is like approaching 0. No electrical conductivity, or very close to no electrical conductivity. So what you should see with the electrical conductivity of periodic trend is that it actually goes up in group 1, 2, 3, and then does what? After going up 3 times or 2 times, then what
It
happens?
decreases by a lot.
It just goes like to 0. Because you're going to be looking to interpret graphs shortly. That's why I'm bringing this up. All right, so that was melting points. Electrical conductivity. Does that make sense? So only metals conduct electricity for pure elements. Non-metals do not. So we have to get out here with that. Actually, why do chlorine and argon, they don't even have approaching 0. They're just like, no data. Like, there's actually data for silicon, phosphorus, and sulfur, but there is no data for chlorine or argon. Well, it can't conduct electricity if it only exists as a gas, right? Because like, there's where the electrons, like they're not even connected to each other. Chlorine exists as a gas, argon exists as a gas, whereas silicon, phosphorus, and sulfur actually exist as solids. So there is measurable, albeit approaching 0, electrical conductivity here, but this is actually because of their state of matter. All right, melting point. This is the most important one and why I chose to put this lesson up with the metallic. Also here, melting point. This graph is important, and you should know it. The trend for melting point from sodium to argon, you need to reverse, and you need to be able to explain it actually. So what the heck is going on here? Sodium, magnesium, aluminum, take a look at it. Why is silicon so high in melting point in comparison to every other element? I mentioned it earlier today. Here, right? Silicon is a giant molecular structure, which means that it has strong covalent bonds. And giant molecular structures have the highest melting point. And that trend is here. Giant molecular is higher than giant metallic, which is higher than simple molecular. So we're looking for, in melting points going from sodium to argon, we're looking for silicon to be the highest because it is the giant molecule. And that's just something you should memorize. All right. The next group would be giant metallic. So take a look at sodium, magnesium, aluminum. What's happening from sodium to magnesium to aluminum?
Magnesium and aluminum are greater than sodium.
So we said silicon was the highest. Then it's actually aluminum and magnesium, but they're very close to each other, and sodium. So far, so good? So what's going on in these three? They're all giant metallics, so what's the difference between them?
The amount of valence electrons.
Right. So the more valence electrons, the higher the melting point. The more valence electrons in a pure metal, the higher the melting point. And the higher the conductivity, right? And so that's your justification. You should have that written down. So when comparing the melting points of metals, we're comparing how many valence electrons they have. So we now have silicon, we have aluminum, we have magnesium, sodium, and then we got basically this is one, this is a group here, and then this is a group here, right? What in the world is going on from phosphorus to argon? They're all low, right? But do you see there is a difference? Cambridge will actually ask you to explain the difference. Why is, this should say sulfur, by the way, that's a mistaken print. Change that from from silicon to sulfur, that's not sulfur. Phosphorus, sulfur. What's going on? Phosphorus, why is sulfur higher than phosphorus and higher than chlorine? Is there some kind of reasoning here that makes sense? So we're talking about the elements here, and we're talking about the standard states. So when we're comparing the melting points, we're comparing the standard states. So how do these elements naturally occur on planet Earth? Sodium occurs as what? NaS. So you may want to write that down somewhere. Magnesium exists as what? Mg. Solid as well. Do you agree? What does aluminum exist as? What's the standard state of aluminum?
Solid.
Yeah. What about silicon? Oh. I have something. I was burning to my chemicals today. I can't remember. But I have some silicon for all of you. Here. Here's some silicon. Here's some silicon. That's just the element silicon. Yeah, it's pure silicon. There's some blocky silicon, and you're like, on what? Safe. Green is generally recognized as safe. So, like, if you see that I'm handing out something like red, it's not safe. Random block of silicon for you to keep. You can keep it as a pet, yeah. Yeah, your own very block of silicon in your life. Here you go. It's a solid. You can't melt it. Good luck trying. Right? I said good luck. Yeah. Did I give you all two already?
Yeah.
Okay. All right, did everybody keep the silicon in their lives? Okay. I want you to notice something, by the way. You need a piece of silicon in your life? No. Knowing that it's a giant molecular structure and how hard it is, why would you do that? It's like saying, can I eat a diamond? Okay, I want you to notice something. Look at my fingers. My fingers. Why is that? Oh, isn't silicon in the same group as graphite? So it has similar properties to graphite. Not very well. But it does rub off like graphite does. Like I was pencil lead, but it's actually the silicon. Interesting. Sorry about that. I just remembered I had some silicon to give you all. So silicon, it's a solid. You agree? I have proof it is a solid. Don't eat it. What? All right, phosphorus. Anybody know what the standard state of phosphorus is? You are supposed to memorize it. Go ahead. That's sulfur. It's P4. And you should know that. So write it down. It's P4 to be clear. And it's solid. That is the natural state of phosphorus. P4. I think I wrote P4 back. Nope. I wrote there. P4. Cl. What's the standard state of Cl? Use the restroom. What else besides gas? What's the amount of chlorine? Oh, sorry, sulfur. What's sulfur first? And it's also 8. And you should memorize that. There are only 2 elements on the periodic table that are diatomic. One of them is phosphorus and the other one is sulfur. I mean, not diatomic, that are polyatomic. Phosphorus is P4 and sulfur is S8. Easy way you can memorize it. If you draw a P and you draw it backwards, it kind of looks like a 4. Like backwards phosphorus. I don't know, I'm reaching, but like P4 backwards phosphorus. And also like S, if you just keep going with your squiggle line, it turns into an 8. So S8. Memorize it. Like S, complete it, 8. Got it? All right. I also have sulfur. It is smelly. What? I'm not gonna give it. Does anybody want to smell it though? You gotta waft it though, or like it's not gonna hurt you, but like you can smell it if you want. Any smell? Did you catch it?
This one has a little bit of fire next to it.
Yeah, it's burnt. Smell it?
Oh, hey.
You kind of gotta take a whiff of it to really get it, but like, ugh.
It's not bad.
Did you catch it? You wanna smell it? Sulfur in your leg? So we remember sulfur is a solid. We also have its color. It's yellow, right? They're not gonna ask about that right here though, but it's a solid and it's S8. I need you to memorize those numbers. P4 and S.
8.
8. All right. What about chlorine?
CO2.
Yes, that is one of my diatomic elements. And it's gas. And argon. Are you okay, Damon? Why are you poking your nose? Like, did it smell that bad?
No, it's not.
Oh, okay. And then argon. All right, now that I've written these out the way that they naturally exist. P4S8Cl2 argon. Can you now make a conclusion on why is sulfur the highest melting point? More electrons. So the order is actually S, then it's phosphorus, then it's chlorine, and then it's argon. And here they're all dispersion forces, right? So it's most electrons would have the highest melting point. So that's how you get this really weird order. So that's why I figured it's best to present this right here in this lesson, because we just went over dispersion forces and molecular forces. The only thing you need to make sure is that you have your standard states for these elements memorized. What are you doing? Are you messing with the silicon? Stop messing with the silicon. Put it away back. Scratch it on the paper. All right. So far, so good? I still see some writing, so I'll hold. Silicon in your pocket. Emergency silicon.
Yes.
All right. So, yes,
Elements are otherwise, right?
technically, yeah.
So, does that have properties of both metal and non-metal?
It's a good conduct. It's a good. Yeah. It's a semiconductor.
How much does a piece of this cost?
Not very much. That's why I was able to give it away. If I can give away something, it can't be that expensive. Not rich. The school's not rich, so you can draw a conclusion from there. All right, here we go. Periodic trends for melting point. Take a look at the bonding for sodium. What would we say the bonding is?
Sodium?
Sodium.
No, bond.
It's a metal, right? Atom. Magnesium. What's the bonding between magnesium? Metallic. Aluminium. Silicon. It's giant covalent, right? Phosphorus.
Covalent.
Sulfur.
Covalent.
Chlorine.
Covalent.
Argon.
Is there?
Trick question. Argon doesn't bond, right? It's a noble gas, right? Doesn't have a second one. It's just argon. All right. Like, just 10 seconds. All right, structure. Giant or simple? Na. All metallic is giant. Magnesium.
Yeah.
Aluminium.
Yeah.
Silicon.
Nice.
Phosphorus.
Simple.
P4 has beginning end, right? P4, there's 4 of them. Simple. Sulfur.
Simple.
Simple. Chlorine, Cl2. Simple. Argon? I would say simple because, it exists. It has a beginning and an end at the same atom. I don't think they'll ever test that, but I'm just saying there's a bonus one thing. All right, so. And I wrote it also here, if you didn't get it before, sulfur is S8, phosphorus is P4, chlorine is Cl2. Argon is not combined with anything. All right. There has been charts on, as you saw in the Millwork, there have been charts on Cambridge tests that look like literally just like this, where you fill in the letter, is it metallic, covalent, ionic? Notice there's no ionic. Is that okay? Can pure elements ever be ionic?
No.
Because it necessitates you have a metal and a
Not
non-metal, which means 2 different elements, right? Have to combine with different electronegativity. So ionic cannot be for pure elements. Okay. Electrical conductivity. This is zoomed in. Relative electrical conductivity. Take a look at the pattern. See if it makes sense. From sodium to magnesium to aluminum. You see it goes up. And then what happens after aluminum?
It goes down.
It goes down. Make sense? Once you cross the non-metal, it's not really conducting much electricity. However, look, silicon does have that small semiconductor. All right, check out from the textbook. Why does sulfur have a lower melting point than silicon? So this is the type of questions you're going to be asked to explain on a paper 2 type set. question. Why does sulfur have a lower melting point than silicon? Where are the creditable marks here? Whenever we talk about melting point, what should we be comparing?
Oh. Forces of attraction.
I want you to write that down. Every time you see melting point, you must be comparing the forces of attraction. Well, what's happening in sulfur versus silicon?
Sulfur has more electrons.
But it says sulfur has a lower melting point than silicon. Right. So silicon is a giant molecule with strong covalent bonds that require a lot of energy. And by a lot, I mean thousands of degrees energy. A lot of energy to overcome. If one of you want to, you could just like consult Professor Google on the melting point of your silicon. Consult Professor Google, whoever has the opportunity to. What is the melting point of pure silicon, which I provided you with today?
570 degrees.
Is that what it says? Oh, 2000. I heard 570. I was like, what? Professor Google, you're wrong. That sounds better. I heard 570. 2,570. And fun fact, I think I told some of you last year. Do you know how hot our burners are? Like our butane burners that we use for labs? No. They are around 1,400 to 1,700 degrees. Fahrenheit. What? Unlikely. That's 2,570. So I don't think so. No, it's still the same energy. It doesn't. Better source of energy needed. Because it's got that hard exterior. So that's the scratching that you're hearing. All right, so it requires a lot of energy to overcome. How many marks have we said so far? Maybe 2, depending on how they credit them. But what else do we have to say? We definitely have not finished this statement. What else do we need to say? Whereas sulfur only has dispersion forces which are much weaker. You could just say weaker. I'm just saying much weaker to exaggerate. Which are much weaker and would require less energy to overcome, right? What is this here? What's the melting point of sulfur? What's that one up? Melting point of sulfur. Yeah. Professor Google. Which are much weaker.
I'm pretty sure it lights up.
Only a mere 235.
Okay, so 235 degrees Celsius for sulfur, right? Versus 2,570 for silicon. It's a difference, right? Like 10 times. That's why I said much weaker. And require less energy to overcome. Be careful with the wording. Don't say held together because dispersion forces are intermolecular forces. They don't hold together molecules. They basically are forces of attraction between separate molecules. So be careful with your wording here. Choose your wording carefully. All right, that was the first type of comparison question. And by the way, Cambridge loves to ask comparison questions. They love to ask this element versus that element, this compound versus that compound. What's the difference? And so you have to research those comparisons. Are you burning sulfur?
Yeah.
So I was talking to A-Level about this. I used to do burning sulfur in the AS class. Not today, but if you want to, I can. However, it's smellier and can give you the fair warning. The only reason I would say that it's okay to do, just remind me when you have a lab, when we do qualitative analysis is you don't have a class after yours. The reason why I stopped doing it is in the last several years, AS Chemistry had creates after them, and can you imagine 4th, 5th, or 6th period coming in? No, no idea what's hitting them, and it's just awful. Let's not be mean to the kids. But you're the last class of the day, so just remind me when we do a lab, we could purple. Because it'll do purple fire, yes. A little flammable, but like, not like by itself. Yeah, phosphorus is super flammable. One of the versions of phosphorus is very flammable, yeah.
What do we burn in creates that we can like?
The flame tests.
Yeah.
Crease is doing that next week. Yeah. All right, let's take a look at the second one. Why does sulfur have a higher melting point than chlorine? So now what's the comparison to make? So I would say, although sulfur and chlorine both have dispersion forces, both have dispersion forces. Yeah, they both have dispersion forces, or ID if you want to say it that way. Dispersion forces. Sulfur has more electrons. And I'm going to write sulfur S8, just to be clear. Sulfur S8 has more electrons than Cl2. Meaning it will require more energy to separate sulfur. Can you prove that sulfur has more electrons than chlorine? Can you prove it? You should write it down, yes. Because, like I said on the test, you're actually going to be given paper 2 questions where you have to make comparisons. So, although this question itself doesn't come from paper 2, this is very similar to how paper 2 questions are. And I'll give you some comparison questions like this on your next bell work, by the way, on Monday, for that bell work challenge. Expect this type of question, but like from a paper 2. That's what I'll be looking for. Okay. Can you prove that sulfur has more electrons than chlorine? How many electrons does sulfur have? 16 times 8. What's 16 times 8? The number 128 is in my head. Check it. Is it 128? Is that right? This was in my brain.
Yes,
But-
it is.
Yes. 64 times 2, 128, yeah.
Yeah.
And then chlorine. How many electrons does chlorine have?
17,
And then times how much?
2,
So 17 times 2 is?
34.
Okay, so sulfur has more electrons than chlorine. You agree? The only way we know this is because we know that sulfur is S8 and chlorine is Cl2. Otherwise, you wouldn't know that. So you have to know the standard state that you're comparing elements in their standard state to each other, not the single atoms on the periodic table. So be careful with that. All right, last set of questions before we move on. Why is magnesium a better electrical conductor than phosphorus? This is a question I've seen in the past. I've seen students get it wrong, and hopefully you shouldn't get it wrong. Why is magnesium a better conductor of electricity than phosphorus? Yes! If you said magnesium is a metal, whereas phosphorus is a non-metal, you get the mark. That's all you gotta say. They are simple questions, but the problem is you get overwhelmed with material in this class and mess up on easy marks. It happens all the time. Magnesium, so what are you comparing? You're comparing magnesium as a metal, whereas phosphorus is a last year. Why is magnesium a better electrical conductor than sodium? The second question.
Is it more electrons or is it because it's alkaline earth
More.
metal?
So there's more electrons. Be careful. magnesium has more valence electrons. Than sodium. Notice I made a point here to say magnesium has more valence electrons than sodium, but you could have said instead magnesium has more delocalized electrons than sodium. Why? The delocalized electrons are the ones that are moving through, that are conducting electricity. You can go outside if you need to. All right, just a reminder on the next slide, ionization energy. I'm not reteaching this right now because we already spent several class periods and reviews going over ionization energy last unit. But just to remind you of the structure of what it looks like. Do you remember this? Ionization energy across the period increases. But you should see there's a dip at group 3 and there's a dip at group 6, technically, right? And those are the two switch groups you needed to be aware of because of spin pair, repulsion, all that good stuff. Remember the exceptions to ionization energy? I'm not asking you, I'm not going to ask for the exceptions on this test. I'm just saying you should recognize the general trend and why there's a switch there. Like there's a switch between 2 and 3 and a switch between 5 and 6. I just rewrote this down. We already wrote it earlier. This is where I wanted to get to. The reason why I'm re-showing you trends we already looked at is because this is the type of question that Cambridge likes to ask. The trends in 3 physical properties are shown, from sodium to sulfur. Which one is not being shown? Can you spot out which trend is not being shown on those graphs? How could you work through it?
Okay, then.
This is atomic size
I might just have to change.
or atomic radius.
I don't know.
I'll give you that.
Sulfur, right? That's the.
This
No, second.
is right there.
Oh, that's ionization. So then
It has the dip at 3 and the dip at 6. That's ionization energy. Right? One of them has silicon super high. Which one is that? Melting point. The one not being shown is electrical conductivity. And what that would that have actually looked like? Like something like that, right? But not exactly. Like it would be 1, 2, 3, and then that. But that's 4. Yeah, shortly. Very shortly. We're almost done. So very, very shortly. The last part of class. All right. Try this one. This is a common type of paper 1 question. This is the last question of the lesson, so we're actually doing a gym kit after this. So last question of the lesson. Which graph correctly shows the relative melting points plotted against their relative electronegativities? I'm going to let you think about it. By the way, I do want to remind you that on the day of the exam, you do need to turn in your binders for Unit 1 and Unit 2. I need to see your Unit 1 and Unit 2 lessons. So make sure you're organizing your lessons together over the next week. You're turning that in on Wednesday. I'm letting you think about it as I'm creating your class and gym kit. All right, let's see. Which one do you want to compare first, melting point or electronegativity? Melting point. So melting point, it says here, is on this axis. So we would look for the highest element to be what?
A or B?
Silicon. So highest on melting point should be silicon, right? So that means that phosphorus, aluminum, magnesium, this has that, C, and
Oh, C, the B.
B has that, right? Silicon's the highest in B and in C. So you should look at each trend individually first. Now look at electronegativity. What's the trend for that? And yes, I didn't put it in today's lesson, but I put it earlier this unit. What's the trend for electronegativity? It's like this, right?
Oh.
Fluorine's the highest, the electronegativity. So comparing the elements, and I guess you could just compare magnesium, aluminum, silicon, phosphorus, right? Electronegativity, what would be the order? Would phosphorus be the lowest electronegativity and magnesium be the highest?
No.
Or would magnesium be the lowest and phosphorus be the highest?
Magnesium lowest, phosphorus highest.
Right,
I mean,
because it goes
phosphorus
lower to
is-
higher this way. So it's definitely
Right. B
lowest.
is at the, E is at the
Yeah,
bottom.
never
of
write
it. It has
anything.
no-
Should be fully understood.
No, the lowest melting point, yeah. Right.
So good.
So that's the type of sorting questions they can ask. All right, so go to Google Classroom. Go to the class screen. Yep, it is time to practice. So our first practice review together is going to be GimKit. Head to Google Classroom. Join into GimKit. I'll give you a couple minutes to transition. Yeah.
Oh, so this is like.
What about your phone? And if your phone don't work, I've got iPad. Yep. Like my own personal iPads. All right, get your technology out. Sign up for GymKit account. You need to get in the class. Mariani and Diane are already in. Still waiting for everybody else. There should be 17 students in the class. I can't create the game until we have the class. So create your account with GymKit now. Gonna do both? Okay. All right, get into GymKit now. How about over here? Do you have a device? Do you have a charger? Do you need a charger brought to you? There's an extension cord. There's an extension cord in the front that could be brought. Are you guys using the extender cord? There's one right here. Like actually, there's one right here. Like literally right here. Oh, you have one more. You mean something you could give him your silicone? All right, let me check everybody's. All right, right now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm missing 5 of you.
You mean the class?
17 people here today. I need 17 people.
Hey, there's 17 people in 12 thumbs. I thought it would work. It is like a.
I'm gonna play more than
Oh, I thought we were gonna have to get rid of
What? David.
some.
I know I would be your first target. I know I would be your first target.
Yeah, I would put some
You wanna
mercury in
know
your
your
water.
friends?
I would put some
Why are
mercury in
friends
your
that
water.
work together?
You're like, what was that? Mercury.
Because
Just some mercury.
yeah, go on the work with
It wouldn't be
each
that
other.
hard to find you.
Like, I got they're nice too, but they like it hurts. Like me all the time. That is the nice friend.
Oh, don't worry about it.
Oh, it is that. Oh no, I am.
All right.
What is that? Oh, that's what that is. Oh, those are.
Oh, I'm better than you. Probably not.
Wow.
Wow.
From level 1
Let me check one more time. I'm gonna start loading the game, so hopefully you've gotten into the class. You go to Google Classroom and you look for the link that I put at the top. And then you get into the class that way. You're in the class? Are you in the class yet? Yeah. All right. Are you in the class?
Yes.
Ready?
Yeah.
Okay. You're in the class? All right, we're gonna start a game. It is the end of the day.
Oh, what the fuck are you doing? I don't know how to play.
Oh, this is the worst.
So,
Or it's just control, then you put.
how many of you have not played Capture the Flag before? How many of you have not played Capture the Flag?
You're not gonna enjoy this.
All right. So, Capture the Flag puts you in two teams, and you have to answer questions to get energy. Then you have to run and get the other team's flag, and then the other students have to protect the flag that you have. So you have to coordinate well together. There's 17 students, so you will not have even teams.
It's
So,
all about winning. It's not about winning. I mean, it's all about winning.
David, stop.
but what if you end up with a disadvantage?
I've been in teams where the other people have more people by like a lot.
Okay.
And they would
So you want to do Capture the Flag?
That's
We did it once in fifth period.
and they lost. The people, more people lost.
We did it once in fifth period.
You go to gym set and then you go.
All right, we'll set it.
Wait.
How much energy should it be per question correct? It should be more than 1,000 because these questions are not the easiest. Do you want to do? I said it should be more than 1,000 because these questions are not the easiest. So maybe set it to 2,000.
10,000.
10,000.
Maybe like 3,000. Wait, did you just say 500?
2.5. You'll never get. Oh,
4,000.
that's fair.
Answer a question.
Why do you do that?
600.
2,500. Okay, fair. Our class, we are AS Chemistry 2023. And joining late means that if you get kicked out or your internet's like the worst, you can get back in.
That's crazy.
So I'm about to put up the code now. The only thing I request is that you keep your language PG.
What's that?
You know what that means? Like a Disney movie. keep it like a Disney movie, and don't threaten each other. I know you're friends, but don't threaten each other.
I'm gonna win.
Who the hell would put it in another person?
I'm gonna take your silicone away. I'm gonna take your silicone away.
But have fun, steal each other's flags. That's fine.
I'm gonna take
But-
your silicone away.
Be nice to each other. That's all I
Alright,
ask.
let's give you that flag. So not like.
Yes, exactly.
Hopefully, General.
Alright.
God damn.
So 800-449. Code is up. 800-449.
You press it, press
My coffee cup?
What the
My coffee pot. Coffee
Hey, look
pot.
at, we're all blue.
Me personally, I could.
We're not on the screen.
Alright. Everybody's in? Just double checking here. Everybody's in?
There's so many Justins.
There's 5.
I'm starting the game. Hakeem, are you in?
Yes.
Okay. 5, 4, 3, 2, 1. Good luck.
Yes, I think there's burn things you gave it.
Why? I'm still loading it.
Oh my God.
Yeah.
Please be on the other one.
Oh my God.
Oh, anyone else?
What team you in?
I'm built different.
Oh wow.
Team you in?
Rose. What do we call Rose?
Wait, did they take away? Okay, they only.
It was in
gave-
today's lesson.
Rose is like,
That's
that's like, Rose is like.
Rose's sideways. It's in the lesson from today.
Yeah. Yeah. It's which products of thermal decomposition of nitrous.
Oh, good job.
No, we
I'm
are.
trying to think of all the more questions.
But that's not right. Is it right? Yeah. Ideal guy.
Yeah, it's ideal.
You clicked before you could finish.
Whoa, what is that doing?
Everybody always wants to do one up there.
All of them have this. All of
Alex,
them
bro.
have a light on. I can't be wrong.
Nah, that is trolling. Bro. That is trolling. Bro, can you stop trolling?
Who's Peter?
Peter.
The fact that you guys don't have your flag is crazy.
I was there. I got where you went.
It's crazy.
Oh, because I'm not looking.
You gotta run and get the other
You did me like this person didn't see it. I don't know. Oh,
You gotta go the other direction from where you begin.
polar? Are you on the north side? Are you white?
Were you tagged?
It's over now.
We're in second place.
Help. Out of 2.
Shit.
I don't know what
I don't know what this is, but I died.
let's go. Let's go. I don't know how to play this.
All of them.
Oh, did you go onto the black side? The board and the flag.
I'm guarding this. Where you going, bro?
There's one.
Where's the bug going?
Where's
Yeah, it's not a flag. I'm coming. I thought I forgot all the questions that didn't too late.
Why are you invisible?
What is a black hat?
David, what are you doing?
Oh my God.
Justin, you
Yo, we're getting
Oh, crap.
destroyed. We're gonna get to work.
Yeah, better.
Wait, is it 3-0?
Get over here.
No.
Camp him. Camp him.
I got the flag.
He will not leave. Get over here. Get over here.
I haven't heard that word in
Where you
forever.
going,
Imani has a banana.
man?
What? He has a banana in his head. That is one of the juices.
Where is the black hat?
You.
I don't know.
You're a flop.
Right, because I know this.
What's his name?
Oh,
No, Leslie.
I
I see you.
In the
She
meantime.
can't leave. I'm you're not getting out of here, buddy.
Have any of you thought about making a gym kit for Monday?
We can do just this. This said Kahoot, but-
Y'all leave me
Yeah, but no, it can be Kahoot or it can be quizzes or it can be gym kit. It can be whatever your preference is.
Watch her like a hop. Watch her like a hop.
Why did I give it?
No.
Ooh, Sophia.
I'm gonna make.
Where'd my defense go?
Only you just fail.
Oh, that's the thing. That's not.
I don't know who Vincent is. Okay, I'm away. I'm away.
We got it.
Shouldn't say that.
Oh my God, it's- I don't understand this.
Oh, I see. Oh, I see.
Oh.
Hey, seriously. Wait, I
What are you doing?
let me get it. I need, you think I'm,
No.
you think I'm a star in the middle?
You have to protect your flag.
What are you doing?
So NICL,
Yes, sir.
metal and non-metal.
Yes, sir.
Definitely be.
Run,
Yes, sir.
Yes,
Yes, sir.
Oh, yes,
Yes, sir.
Oh, you have to upgrade.
I've got
Upgrade to get faster.
This upgrade?
Yeah, there's ways to get faster.
Over here.
That's where we will.
I think like this.
Echo has a point. Count one S and two P. One S.
Echo.
Yeah.
Hey, you did the thing.
One S.
No! No! Oh my God.
There's no way.
Electronics.
There's no way.
So you got no money on the cover.
Oh, right.
Bro, there's no way.
You just ran into it.
Anyways.
I got the point.
Anyways, I was eating.
Oh my god.
Echo has a point.
You're right there.
I don't even know about this.
I think Vortex has 5 points. Echo has a point on the board.
This is oxidized. What's oxidized?
Answer sodium.
Yo.
Loses electrons the easiest.
But why did I get it back if it didn't even happen?
No.
That's one of the things I forgot to take out.
Get over here.
Oh,
Nah, you come over
I
here.
only played this game once, and it was in your
Nah, bro, you come over here.
I remember those who go here.
Yeah, Roz up there.
You're right. You're right.
I'm doing something.
There's no one.
I just assumed you weren't. Julio, turn in this one. That's David, bro. David.
I never know where he is.
Where's David?
I would just stay in here.
Even when they're holding the flag.
I'm away. I'm away.
Highest ionization energy. Remember, ionization energy is this way, like that and that way.
NP1, what the NP1?
Stay in the middle.
So what ends like 3s2, 3p1? What group would that be?
I think all men are all.
go with the strongest. Cause yeah, I technically should also be guys are also. So like 3s2, 3p1.
I'm out of here.
N means like random energy level. Like 3s2, 3p1. 13.
No.
3 valence level.
Nah, bro.
Yo,
We just did that.
Echo has a second choice.
Carbon dioxide has.
It's a converter.
Oh my god. Oh my god, no, wait.
How's your time? You've got. Why did you say?
I don't like
7 seconds.
Is that all there is?
No.
Oh, I didn't adjust the time. Oh, well, it looks like we have.
We won.
We got 2 points.
I did all those scores.
We got 2 points. They had like 5.
Bro, I captured the flag 8 times.
Do you want to try something else? I think kind
Let's run it back.
They kept getting caught. I didn't really know what I was doing till like the second part of the game.
I think everybody.
This one. I did all those
Yeah,
scores.
well,
I did
yeah.
all my work.
Hold up, hold up.
It turned invisible. You could also
there's
just.
a couple of different ones. You
That's
can
what I
do-
did.
Are we supposed to talk?
I didn't bring her to
Yes, yes, we are. I've never heard of that. I want to do it.
Oh yeah, I can see you.
Are we supposed to have
Yo, you know what I can see right now?
Zombie?
I can see you.
Almost.
I've never played this game.
Neither have I.
Wait, what is this?
No, I feel
Half
like
of you are human, half of you are zombies.
Ooh, I want to be a zombie.
I don't know what it does.
Yo,
I don't know this game. You don't want the sleep power? You want? Don't want to just like use anything?
Yes.
I
Alright.
can see you right now.
I don't know what this does. Good luck. 29, you're the tester here. You're the experimenter. 296 170. You gotta enter a new game. We got enough time for one more game.
get ready.
One short game. Humans versus zombies. You're gonna be my group that lets me know if this is a good game to play. All right, still waiting for a few people to get logged in. I don't know who's human. I don't know who's zombie.
You want to draw?
I do want to.
What the hell are you gonna do with that? You guys going back.
Oh, why?
Oh, it's this mode? Oh, this
What now?
No, this is just brown.
All right, we are starting. Or I'm hitting next in 5, 4, 3, 2, 1. I don't know what happens next. All right. Human.
I'm gonna need you.
Zombie.
I'm a zombie.
Start.
Are you human?
I don't know what's gonna happen. Good luck.
We already know what.
Yeah.
That sounds amazing. Let's do that.
Okay.
Zombie or human?
What happens to friendship?
Human or
What's
zombie?
that? Never heard of it.
Decided.
All right, good luck.
Wait. Hear me out. We need a plan.
I don't know how this works. Good luck.
I'm losing dollars.
I'm losing health per second.
We're negative.
No, we're not.
Yes,
Hey, how do you know?
because I can see it. So zombie. No, we're losing health per
Ions
second.
are the ones without less electrons, right?
Oh, they have to purchase a fridge maybe to protect your health.
Ah.
I lost my money.
Oh, yeah. Which is true about that shaker.
What do we think? I'm negative.
Now. Well, I wasn't wrong.
Oh, I'm gonna
Certain products of thermal decomposition.
Wait,
When I brought it up.
Do you guys know this one?
because if I were able
Oh,
to give you
that's
money,
not
I would
gonna be on
give
the
you
set.
all of my
Oh,
money
we're
so you
gonna take
keep
it out.
covering.
Oh, wait.
Metal,
Wait.
that carbonate, metal oxide carbonate,
Personal.
Metal oxide
and carbon dioxide.
Another one.
The red one, right,
I'm sorry.
right. Too much for cake.
How do you have negative money?
All right, right now I believe you're tied. You're tied. What's going on? Is there a way to protect yourself?
Yeah, you're supposed to go to the shop. Every time you get one right, you get money, and then you go to the shop and that's it.
Okay.
I assume.
Do they have partial charges or?
Oh, bro.
Correct answers.
Bro.
Yeah.
What?
I think you just have to pick one of the two correct answers.
We just have to be better.
What's up, bro?
I think that's two, right? Two carbons.
What
Help
is this
side.
shape? This is
What's the name of that thing?
this is a tetrahedral.
Are there 4 groups?
No,
Tetra's the prefix for 4.
right now, like that makes sense.
There you go.
That makes a lot of sense.
Sure. Negative six.
Oh, this costs a lot of money.
How much is it?
$100.
Anybody got any help?
Oh.
I have 14 bucks.
Which is 1.5 per
Anybody has 10 dollars for something?
That's it.
Oh, you get honors. 20 per question.
You're almost halfway out of health.
We need $5.
And multiplier as well.
So,
What's the bottom angle?
Boom.
yeah, I can roll.
Wait, you guys want NH3?
Oh, just
NH3. Oh my. How do radius is I think it's I think it's this one.
Oh, H3.
Right. Anyway, tetrahedral. Angles.
Association quad angles, it's a thing.
Yeah.
Don't forget to study that.
Yeah, there you go. Just follow it. They do have the highest number.
Why is it always London?
Just follow Yes.
Right now, you're all at a tie.
Okay, I'm gonna go. Actually, no.
That's, oh, hold on. Oxidizing agent reduces scoring. Thank you.
Yeah.
How do
How much money do you
I know.
No, that's, this is the humans in total.
No, you can go to the shop. I got 12 dollars.
You gotta get money.
If you get the 30,
Yeah.
push the.
Adam.
Shop. You go to the shop.
That was the diapers, right? The negative
You need to buy.
I'm in the shop.
You need to buy 100. Oh no. Yeah. 100.
It turns really harmful gases.
Here.
I thought it was, isn't that catalytic?
What the hell?
Isn't it catalytic?
Oh, here.
That's what I was thinking
We're gonna
about.
learn about that. We're gonna learn about like.
Yeah, but we need to.
It's actually a part of the part. And it basically turns like really harmful
Please help
gases.
by 30, okay, 1 5
Like,
double.
carbon monoxide, carbon dioxide.
Right.
180 health.
Wow, we're all fighting.
Yes, nobody has been able to bring
Bro,
this
you're a zombie.
I didn't spend the next week
Volatile means most easy to evaporate, which means lowest melting point
Right, so the lowest melting point would be.
out of those. Yeah, that's ATL and 85. Uh-oh. Reminds me of the floor is lava right now. Have you ever played the floor is lava? Yeah. I played it, I tried it one time with Freeze and it was a tragedy.
Negative $3.
How? Because like the whole class just lost like in 2 minutes.
And then 9 usually. Larger?
So I haven't tried it again.
Yeah, $5. Which is the following
So
color?
NaCl, metal and non. But it's got a metal and a non.
Yep.
Oh no, it's almost over.
That's still organic.
Oh wait, there's humans are winning.
What?
What? The humans are winning. The humans repaired.
Yes.
Which is the following is more utility optimized? Shut, let's see.
Oh no, zombies! Zombies are losing. Zombies are like about to be gone.
No.
They're about to be gone.
Can we pull all of them?
That would be nice, right?
I'll buy the night.
You see this thing? What the hell is
Leave it alone. Leave it alone. Leave it alone.
Looks like that's the game.
We lost.
Humans win. Humans win.
Oh.
All right.
You're not that guy, man. You're not that guy.
All right, so we are really getting to the end of class. Congratulations, humans.
Yeah.
Yeah, that's what I was great.
Sorry, zombies.
I don't see you.
That's not how I feel about this game.
You only had $30.
That was my final balance.
All right, just a couple quick announcements before we go through the day. Let me get your quick attention. So 5, 4, 3, 2, 1. I need everybody to quiet down for just a moment. I am about to pass out homework. So you have homework. It should also auto post online. I always set it up that way. So make sure you finish this along with your project. You've organized who's doing what. Choose what type of game you want to make. If you like Gym Kit, you can make a Gym Kit. If you like Kahoot, you make a Kahoot. I suggest those two. You want it online, right?
Good afternoon, Golden Light. This is Emily, and these are your afternoon announcements.
Students, please remember to check the cameras, email daily, and report to school proper TI uniform. Make sure your outwear is solid white, black, or red. Also, please wear your student ID badge or tag at all times. Protect the student today.
Please remember that you must wear your student ID every day. If you lost your ID, the cost for replacement is $5. If you receive a replacement ID, you must pay for it. Students who have $50 will not be allowed to leave.
Yearbooks are on sale now. They are $50 until October 31st.
Great. Hold on, let me see. They might be somewhere. Let me see if they fell somewhere else.
Students interested in NHS, your application is due ASAP. Link to the application was sent to your camera team.
Attention students, City Club will have our next meeting on Tuesday, October 3rd at the school in Newton 200. Join to learn more about it.
That's so weird. If you didn't get a copy of the paper, pick it up for me tomorrow in the morning. For some reason, I don't see all it. Like I only have that much.
Teachers, please report to the unfortunate 233 our SR
This concludes the afternoon announcement. Have a great afternoon, CIE.
Just a track.
Listen, the moment you said it was giant, I thought it would be like that.
Alright, your next one. The morning homework. Give me the morning pick up the homework. Wait, where's the homework? Give me the morning pick up the homework. I'll give you a copy. For some reason, I had this message that you have, but I printed it. Sorry about that. Just stop by and pick it up for me tomorrow. I'll print them out tonight.
Hey, bro, that's 3. I have 3 math.
Don't forget tutoring on Tuesday as well.
No, hey, if you don't want to give our tutoring, I have sulfur.
What happened?
He's throwing away. He's throwing away my silicon. Give him my silicon back.
That's a silicon bag.
Can I smell something?
No, that's it. That's it.
I will
That's
give
it.
you. I will
Fine.
give you another one. I do not want to. Do you want another one, Ben? You want to smell sulfur?
Sulfur?
Burn it. What?
Exactly.
You want to smell sulfur?
I know. And then I walked away and
We will, and sometime in the near future, we will have to. You can't help but smell ammonia and out.
Ammonia does, I know ammonia smells bad.
No, everybody out.
and neither of us would actually admit to that. So you kind of already had it.
I didn't almost hear it.
And I just basically
And I didn't even have it
deal
at a high
with myself.
concentration.
So it's not like
I smelled it at a high concentration before. I was like an actual pain. Okay, like struggle. It was bad. I needed to show it to the level for something. You have to use concentrated ammonia for something they level chemistry. But like, I was like, okay, Matt, from now on.
I don't know, I wanted to wait, but I don't know to wait.
it's like having a technical. And that's good. Yeah, that's my name.
In the second year, they do like an analysis of the panels, but I don't know if they're having fun. Not actually. But I still have to show like demonstration. It's a lab. It's like, it's not a final thing. You always do labs. We've just been in the third. We're about to move to the lab section in Unit 3. Unit 3 was
Orange, that's crazy.
Gonna get this burn thing.
Damn, bro.
Yeah.
Your nose is
How much rain are we gonna be allowed to burn?
Niall Red, he's the
I mean, if you're feeling that bad, I just want
I love them
to.
so much.
I mean, I talk in Celsius.
I know, like, a lot of people have been feeling bad. Someone got it and everyone's got it.
What do you have? Like,
I know one of my friends was sick and he came out and was sick too.
PSAT, 10th graders. PSAT info. 10th graders, PSAT, October 19th. 11th graders, 11th graders, October 20th. PSAT. All right, have a good day.
What are your PSAT scores, man? What are your PSAT scores? Awesome. 1,200.
No, you didn't.
That's not true. That is not.
Something that looks like
The ESAPN from 0 to 1,500.
look at you.
From when you get to 1,000.
So from 1,000.
I don't want to hear it.
I think I have.
Yeah, from 1,900 is good.
It's not fair. Congratulations, that's pretty not.
How
did you get 1,000
I do not advocate that.
How did you, tell me your secrets.
I don't probably.
David, tell me your
I do
secrets.
not advocate for Oh, I have glycerin.
Glycerin?
He's throwing fireballs.
Oh, no. That is scary.
I love this man so much. Oh my god.
That is not something we can do. But I do have glycerin.
So it's for the.
So we will test it whenever you want to.
No fireballs?
No. I mean, we're not there to fight. Why do you want to fight us?
No, because it's
I said it, not fire. I started my class not filled with fire. Many accidents will not set on fire.
Do not set on fire the school.
That's pretty much the only rule in the classroom, right?
Do not set on fire the school. Thank you. We can do fun experiments, but let's not do that. Thank you. Yes. I like to hear.
Write something down that would
Okay, so you gotta get a job that's like, there's a job you could have like that you can efficiently blow stuff up, right? Like, take out old buildings. Like you said.
No, not a random one. We obviously do.
Like that, there's a job for that.
I build my like private property. I should be able to like burn it down if I want to. Right?
I need my notebook. You left it. You left it in class last class, or you were doing it? No, I was in your last class. One of these? Okay. Can you reach it? Or just the right one? Yeah. I can give you the. Well, yeah. Well, I'm guessing everything's recorded, but like, yeah. I can give you the notes. I posted them online, the actual notes. Yeah. But I can give you the handout and the homework. Remember, you do get extra time to turn in the homework. So you'll have till not tomorrow, but the compactor, which is Tuesday. Thank you so much. I saw. We call it a posse, right? What? Oh, all of them? Good luck with that. Huh? I said good luck with that.
I don't know why they're so obsessed with me.
You could call it a fan club.
They are my fan club. Let's make it look.
You have your own fan club.
No.
You okay?
No. I broke my
That sounds like not okay.
Oh my god. It's whatever.
All right, bye.
Thank you.
You're welcome.
You guys, hold on a second.
Okay.
Teachers, just a reminder, we have the faculty meeting in the auditorium. Thank you.
I guess that's fair. Oh, I'm so hungry.